Anti-Nutrients, All You Need to Know by AZLAN ADNAN, M.A. Thursday, 14th of August, 2025. Anti-nutrients are naturally occurring compounds in plant foods that can interfere with the absorption of nutrients, reduce protein digestibility, or in some cases, cause adverse health effects if consumed improperly. Common examples include phytates, oxalates, tannins, lectins, protease inhibitors, cyanogenic glycosides, and saponins. While often viewed negatively, many anti-nutrients also provide health-promoting properties. For instance, phytates and tannins are potent antioxidants, contributing to the body's defense against oxidative stress. This dual nature makes anti-nutrients a classic double-edged sword in nutrition. Understanding anti-nutrients helps guide safe preparation and consumption of plant foods. Proper soaking, cooking, fermenting, and food pairing can minimize potential risks while retaining nutritional benefits. A balanced diet with a diversity of fruits, vegetables, grains, legumes, nuts, and seeds ensures the body gains the advantages of these foods while mitigating anti-nutrient effects. It is vital to understand anti-nutrients because unwittingly consuming them, as we shall see below, can defeat and undermine an otherwise nutritious diet. This paper will help you to not only identify and minimize anti-nutrient intake, but also understand their deleterious effects. Table of contents. 1. Alkaloids. 2. Cyanogenic glycosides. 3. Glycolic acids. 5. Goitrogens, glucosinolates, thiocyanates. 6. Lectins. 7. Oxalates. 8. Phytates, phytic acid. 9. Protease inhibitors, trypsin inhibitors. 10. Saponins, tannins. 12. Uric acid, purines. 13. Key takeaways. Alkaloids, naturally occurring plant nitrogen compounds. Alkaloids are nitrogen-containing compounds produced by plants as a defense mechanism against herbivores. Common examples include caffeine in coffee and tea, solanine in green potatoes, and tomatine in tomatoes. Some alkaloids are beneficial at low levels, like caffeine, which can enhance alertness. Others can be toxic, particularly in unripe or sprouted plant parts. Green or sprouted potatoes contain solanine, which can cause nausea, vomiting, and neurological symptoms if ingested in sufficient quantity. Cooking generally reduces alkaloid levels in edible plant foods, but raw consumption, such as juicing unripe tomatoes or potatoes, can pose risks. The key takeaway is moderation and proper preparation. Avoid green, sprouted, or unripe plant tissues and cook foods thoroughly to minimize alkaloid exposure. Cyanogenic glycosides, plant compounds that release cyanide. Cyanogenic glycosides are naturally occurring compounds in plants that release hydrogen cyanide when metabolized. They serve as a defense mechanism to deter herbivores. Common sources include cassava, Manihot esculenta, bitter almonds, flax seeds, stone fruit kernels, apricot, cherry, peach, and lima beans. Concentrations vary by plant variety, growth conditions, and preparation. In humans, excessive ingestion can lead to cyanide poisoning, presenting with headache, dizziness, nausea, vomiting, rapid heart rate, and breathing difficulty. Severe cases can result in seizures or death. Chronic exposure, especially from improperly processed cassava, is linked to tropical ataxic neuropathy and konzo, which cause muscle weakness and gait abnormalities. Both cassava roots and young leaves contain cyanogenic glycosides. To safely consume roots, peel, chop, soak in water, and boil or pressure cook. Leaves or shoots should be washed thoroughly and boiled or steamed for 15 to 20 minutes, changing the water if possible. Raw consumption is unsafe. Livestock are also susceptible to toxicity when fed improperly processed cassava. Glycolic acid, a bean-derived toxin. Glycolic acid is found in genkol beans, Archidendron pauciflorum, commonly consumed in Southeast Asia. The compound can crystallize in the urinary tract, causing genkolism with symptoms resembling gout or pseudogout, severe flank pain, hematuria, and potential urinary obstruction. Consuming large quantities raw or lightly cooked increases risk. Traditional preparation often involves soaking beans in sand or water to reduce toxicity, followed by thorough boiling. Hydration and moderation are essential to prevent crystallization. FODMAPs, fermentable oligosaccharides, disaccharides, monosaccharides, and polyols. FODMAPs are short-chain carbohydrates poorly absorbed in the small intestine. They include fructose, lactose, fructans, galacto-oligosaccharides, and sugar alcohols like sorbitol and mannitol. They are present in a wide range of foods, including fruits like apples and pears, vegetables such as onions and cauliflower, legumes, certain dairy products, and sweeteners containing sugar alcohols. In individuals with irritable bowel syndrome or other gastrointestinal disorders, high FODMAP intake can cause bloating, gas, abdominal pain, diarrhea, or constipation. This is due to rapid fermentation by gut bacteria and water retention in the intestine. Managing FODMAPs involves temporarily limiting high FODMAP foods, gradually reintroducing them to gauge tolerance, and using thoughtful food pairing to reduce symptoms. Professional guidance ensures nutritional adequacy. Goitrogens, glucosinolates, thiocyanates, thyroid-interfering plant compounds. Goitrogens are naturally occurring substances in cruciferous vegetables, cabbage, broccoli, kale, and other foods that can interfere with thyroid hormone synthesis. They include glucosinolates, which convert to thiocyanates. In healthy individuals with sufficient iodine intake, moderate consumption is safe. Excessive intake of raw goitrogenic foods, especially with iodine deficiency, may contribute to thyroid enlargement or hypothyroidism. Cooking, fermenting, or steaming significantly reduces their activity while retaining many beneficial nutrients. Lectins, the hidden risk in undercooked legumes. Lectins are carbohydrate-binding proteins in many plant foods, especially legumes. Certain lectins, such as phytohemagglutinin in red kidney beans, are toxic if not fully inactivated. Cases of food poisoning have occurred when beans were cooked at insufficient temperatures, such as slow cooking at 80 degrees Celsius. Safe preparation includes soaking, discarding soaking water, and boiling or pressure cooking legumes for adequate durations. Traditional methods, such as soaking pulses overnight and changing the water multiple times, are highly effective. Oxalates, calcium-binding plant compounds. Oxalates are found in spinach, beet greens, rhubarb, and taro, Colocasia esculenta. They can bind calcium, reducing its bioavailability and potentially forming kidney stones. Consuming raw high oxalate vegetables, such as red spinach, can significantly lower blood calcium levels, while cooking neutralizes much of the oxalate. Taro leaves and sap contain sharp oxalate crystals that cause skin irritation but act as natural pest deterrents. Cooking or thorough handling mitigates risks. Phytates, phytic acid, mineral-binding compounds in seeds. Phytates are phosphorus-containing compounds in cereals, legumes, nuts, and seeds. They bind minerals such as calcium, zinc, and iron, reducing bioavailability. Even moderate intake can significantly affect mineral absorption. Traditional preparation methods such as soaking, fermenting, or cooking help reduce phytate content. Personal experience has shown that daily consumption of raw red spinach caused calcium levels to drop below half the reference range, emphasizing the need for cooking. Phytates also have antioxidant properties, exemplifying the dual nature of some anti-nutrients. Protease inhibitors, trypsin inhibitors, enzyme interfering compounds. Protease inhibitors reduce the activity of digestive enzymes like trypsin and chymotrypsin, impairing protein digestion. They are abundant in legumes and some cereals. Cooking, soaking, and fermenting these foods effectively deactivate these inhibitors, preserving protein digestibility and nutritional value. Saponins, bitter, foam-producing compounds. Saponins are glycosides found in legumes, quinoa, and certain herbs. They can reduce nutrient absorption and cause mild gastrointestinal irritation if consumed in high amounts. Soaking and cooking significantly reduce saponin content, making these foods safe to consume. Saponins also exhibit antioxidant and cholesterol-lowering properties, highlighting their dual role. Tannins, polyphenolic anti-nutrients in plant foods. Tannins are polyphenolic compounds present in legumes, grains, nuts, tea, and some fruits. They can bind proteins and minerals, reducing bioavailability. Their antioxidant, anti-inflammatory, and antimicrobial properties confer health benefits, making them a double-edged sword. Traditional processing methods, soaking, fermenting, blanching, or discarding initial cooking water, mitigate anti-nutritional effects while retaining beneficial properties. Uric acid purines, metabolic byproducts affecting joints. Purines in foods are metabolized into uric acid. High purine intake, dehydration, or genetic factors can lead to uric acid crystallization in joints, causing acute pain known as gout. Crystal formation is influenced by hydration, genetics, and consumption patterns. Maintaining adequate water intake, moderating purine-rich foods, and balancing diet help prevent uric acid accumulation. Key takeaways: safe preparation and balanced plant diets. Many plant foods contain naturally occurring compounds, antinutrients, that can reduce mineral absorption, interfere with protein digestion, or cause adverse effects if consumed improperly. Simple preparation methods greatly reduce these risks while preserving nutritional benefits. Soaking. Soaking legumes, grains, and some tubers leaches water-soluble anti-nutrients, with multiple water changes further enhancing effectiveness. Cooking. Boiling, steaming, roasting, or pressure cooking deactivates protease inhibitors, lectins, goitrogens, and oxalates. Pressure cooking is especially effective for legumes. Fermentation and traditional practices. Fermentation, blanching, and discarding initial cooking water can further reduce anti-nutritional compounds while enhancing nutrient bioavailability. Food pairing. Combining foods thoughtfully can mitigate anti-nutritional effects. For example, pairing high oxalate foods with calcium-rich foods or legumes with vitamin C-rich vegetables improves mineral absorption. Hydration. Adequate water intake reduces the risk of kidney stones and supports digestion. Handling precautions. Plants like taro and cassava contain sharp crystals or cyanogenic compounds. Careful handling prevents skin irritation or accidental toxicity. Health monitoring. Individuals with pre-existing conditions may benefit from periodic medical checks to ensure safety and nutritional adequacy. Moderation and variety. Even safe foods can be problematic in excess. As a rule of thumb, aim to consume at least 30 different plant species per week, eating raw when safe, but applying proper preparation whenever necessary.
Share your thoughts in the comments below. Don't forget to like this video and subscribe to our channel to show your support.